As a warm-up, let's look at this. If f of x equals x squared plus 3, find f of 8 minus root x. So in this f of x equals x squared plus 3, every x that you see needs to get replaced with 8 minus root x. So f of 8 minus root x equals quantity 8 minus root x squared plus 3. This is technically already an answer to this question, but let's go ahead and simplify, just mainly as a reminder that squaring does not distribute when you have a minus sign in here. So we can FOIL this out and have 64 minus root 8x minus root 8x, or it should be minus root 16x. And then finally a plus root x, negative root x times negative root x would be a positive x. And then still copy the plus 3. And we can simplify by adding the constants together, but that's really about it. Now, put a star by this. This is going to be important. A little later today, we will use if f of x equals x squared plus 3, then f of 8 minus root x equals quantity 8 minus root x squared plus 3. We are going to use that, so put some kind of mark, maybe a star, something to let you look back to this moment in your notes. Now, if f of x equals x squared, is f of a plus b equal to f of a plus f of b true or false? Why or why not? This is false. Let's go ahead and pick a to be 3 and b to be 4. Then the left side is f of 3 plus 4. Now this is not the time to try to distribute f, because that's what we're trying to talk about up here, if that's okay to do or not. So we'll simplify the 3 plus 4 inside the parentheses to 7. f of 7 here is going to be 7 squared, which will simplify to 49. On the right side, we have f of 3 plus f of 4, which is 3 squared plus 4 squared. Sorry, there should be that should be an equal sign here. That'll equal 9 plus 16, which is equal to 25. So you have 49 versus 25. Those are not equal. So in general, f of a plus b is not the same as f of a plus f of b. It is not a thing. It is not allowable to take a function and to just distribute it, in quotes. All right. So if you have one function f, you cannot distribute it like this, right? So you cannot have f of a plus b equals f of a plus f of b. That is not allowed. However, the following are allowed because these are new definitions. So f plus g of x equals f of x plus g of x. And f minus g of x equals f of x minus g of x. And fg of x, or rather f times g of x, equals f of x times g of x. And f over g of x equals f of x over g of x. So think of these four as new formulas. They're really actually new definitions. Let's go into detail on one of these four. So what does f plus g in parentheses of x in parentheses equals f of x plus g of x really mean? What's going on here is, say you're given two functions, one named f and one named g. Then we're creating a new function. So there's a third function that's created out of these two functions. You have a function called f, you have a second function called g. We're now creating a third function called f plus g. That's just its name. It is called f plus g. Then f plus g, that function, what happens when you feed in x as input? The output is actually what f of x would be plus what g of x would be. So, to put this in words, for the input x, what is the output of f plus g? It's f of x added to g of x, or it's when you feed in input x into f, whatever output you get, added to whatever, when you feed in the input x into g, what output you get. You add those outputs together. Okay, yeah, that's just to clarify what this is up here. F of x is the output of f when the input is x. Yet you really need to use this language of input and output. If you don't use that language of input and output, all this is just going to be confusing mumbo jumbo. So make sure to be using this kind of language. F of x is notation. Be sure to say the f of x, and it represents its notation for the output of f when the input is x. Okay, so to summarize the language that's here, this is not as specific because it doesn't mention x, but I hope this summary is helpful, that the output of f plus g is really the output of f plus the output of g. So those are these four new formulas, these four new definitions. They create four new functions out of two old functions. Let's practice. So they'll stay up at the top of the slides each time for reference, but let's go ahead and practice. So if f of x equals 5x plus 1 and g of x equals x to the fourth, find f plus g of x. Well, f plus g of x is just copying from up here. It's f of x plus g of x. And then we just replace the f of x with 5x plus 1. And then after copying this plus sign, which is right there, we replace g of x, which is x to the fourth. And here, you can technically drop all the parentheses. It won't change the meaning according to order of operations. But we just thought we'd leave the parentheses here so it's a little clearer where all the pieces came from. Now, follow-up question to this. Starts out the same. If f of x equals 5x plus 1 and g of x equals x to the fourth, find f plus g of 2. That's the difference. We're actually going to work off of what we just did before. So we'll copy down that f plus g of x equals, skipping the work in the middle, we had 5x plus 1 plus x to the fourth, copied from the previous question. And then in this, to get f plus g of 2, take a look at this line. Everywhere here that you see an x, you just need to replace with a 2 instead. Okay, we won't bother simplifying the number. That could be done without too much work, but I think the key thing to point out here is this is a new function, and for a function, when you're asked about what happens with a specific input like 2, you just got to replace all of the x's with a 2. Okay, if f of x equals 5x plus 1 and g of x equals x to the fourth, same setup. Now, new question, find f minus g of 2. So first we'll find f minus g of x. So 5x plus 1 minus x to the fourth. And then let's plug in a 2 everywhere, one line below. So f minus g of 2 equals 5 times 2 plus 1 minus 2 to the fourth. So we've now practiced the first two formulas here. Let's take a look at the next two formulas. So if f of x equals root x and g of x equals 2x, find fg of 9. So first, let's find fg of x. Okay, so fg of x should be f of x times g of x, in other words, root x times 2x. And we could drop the parentheses, but maybe it will look confusing, so let's just leave the parentheses there. So then fg of 9, one line below, just replace every x with a 9. That's how we get fg of 9. So notice if we just replace that x here with a 9, replace this x with a 9, replace that x with a 9. So fg of 9 is root 9 times 2 times 9. Now, there's no distributing here to speak of. There's no plus signs. We just need to simplify. 3 times 2 times 9, which will be 54. If f of x equals root x and g of x equals 2x, same functions again, let's find f over g of 9. So f over g of x is f of x over g of x, so f of x is replaced with root x over g of x, but g of x is replaced with 2x. Now, one line below, all we do is replace every x with a 9 again. So we end up with root 9 over 2 times 9. In other words, we have 3 over 2 times 9. Now, we could do 2 times 9 and simplify, but actually, it might just be easier to cancel a factor of 3 on top and bottom. So you have 1 over 2 times 3. In other words, you have 1 over 6. Interactive question. If f of x equals 2x and g of x equals x squared plus 10, find f minus g of 3. Is it 3